Okay, so a little update on controller number 3, which is this. So I wanted to basically just repair this motherboard and then completely reassemble this and then hoping that it fixed the problem. But instead I decided to go through with the idea I already talked about in the introduction. And basically what I want to do is take controller number 1, with the broken shell. This thing is completely working and I want to basically put this version in this shell so that is completely working, and I want to work on controller number 3 later, because of course this has a faulty stick and stuff, and we need to do quite a lot of things, and that's not a problem. But I thought it might be interesting to install some Hall effect sticks onto this motherboard to basically for me try out and see how that works with the Xbox. I've only really replaced Hall effects in the PlayStation 4 controller, and that has been very successful for me. So I basically want to save this motherboard since I know it's faulty, and then just test out the Hall effects in this controller piece and see how that works. But I want to save that for the end of the video, I think, since it's purely experimental. So yeah, what I will do now is I will clean off the plastic parts, and then this whole piece can just basically go in here, and then that controller should be fixed. So yeah, let's do that right now. So after swapping the shell of controller number 3 onto the motherboard of controller number 1, I tested it on the PC and I did not find any problems with the controller. Everything was working fine, from the analog sticks to the shoulder buttons to the rumble motors. Everything was okay, but unfortunately, when I went to test it on the Xbox, when trying to play a game, I found that the right front shoulder button was not working properly. So it felt very clicky to me, the button, but it just did not register at all. So I had to take the Xbox controller to the blue mat again, and basically I had to replace the whole button again, or for the first time actually. So luckily I only needed to take the front shell off and the back shell, and it was a very easy swap. So I just took the old one out and replaced it with a new button, and after that I tested it again on the computer and it was working completely fine after that. I still have no idea what was wrong with the old button, because it responded very well. So it was very responsive, very clicky, and sometimes it would work consistently again as it did when I tested it for the first time on the computer, but unfortunately it was not consistent, so after replacing it, that was solved. So let's now test the button on the PC again. So here we are with controller number 4, and as you can see I have already taken the controller apart. I just tend to do that off camera because, no, well, why not? Just saves a little bit of time, I guess. And what was wrong with this is that the controller had no power at all. And yeah, if you look at the USB port, it does not look too bad, but yeah, it could definitely be the issue we are having. Of course, it could also be something on the motherboard itself. And yeah, if we look at here on the motherboard, you can see right here, there's something on here. I'm not sure what it is. It's a little bit sticky. So I hope there's not really any damage on the board or any component that causes the no power. I definitely hope it's yeah, possible to fix the issue relatively simply without having to probe the whole board. But yeah, let's first just get down to the second board, and yeah, let's inspect the USB port a little bit better, and maybe it's a good idea to do some measurements, just like we did with controller number 2, to see if the USB port is working okay. Oh, and this controller is basically the first version of the Xbox One controllers that came out, so I believe this controller does not have Bluetooth and does not have a headphone jack, which in the later versions that is yeah, which is in the later versions of the Xbox One controller. And to get down to the motherboard here, we need to remove the rumbles right here with the soldering iron, so let's do that right now. So now that the rumbles are removed, we should be able to take out the second motherboard. I also removed the 2 screws that hold it in. And there we go. And yeah, as you can see, the thumbsticks are basically busted, mainly this one, but this one also is not in the best shape anymore, so I will just replace the 2 of them. So these are going into the trash. First impression of the second motherboard is I don't see anything really wrong per se. There are of course some white spots, but that could also be some flux. I don't really see water damage of any kind sticking out. And as I say that, I see on the thumbstick here there is a little bit of rust right here. On top of here it seems a little bit rusty. Don't know if it's easily removable. Seems to get off the solder joint relatively easy. So I'm not sure what it is, but yeah, we will give the motherboard a tool clean at least to hopefully eliminate future problems. I mean, this to me could also be some signs of old flux, or it could be early signs of corrosion. But yeah, let's just clean it up later. I will first want to focus on the main board. So yeah, let's take out the screws for that. Oh. So here is the main motherboard with the USB port, of course. If I inspect this very quickly, I don't see anything very outstanding. Maybe this cap right here looks a little bit off. It's mainly very grimy, not necessarily big signs of water damage. And even the USB port does not really look that bad, if I'm being honest. It's probably not a bad start to start measuring on the USB port to see if everything is fine there. So we're going in continuity mode. This might be very badly visible for you, but I will try to explain what I'm doing. So first we're going to the very left pin, then to this cap, and that shows up okay. Then I think the second pin of the left is ground. Oh, never mind. Even for me it's not very visible. Might be going to this resistor. It has been a while since I've measured these ports. And it's not a very strong continuity. Okay, now it is. Okay, now the middle pin goes to the resistor next to that one, and that is also fine. Then the fourth pin, I think, goes right there. And I need to press very hard to get some continuity. It does not seem to be a very strong continuity path, so that could be something. Then the last pin should be ground, which that is perfectly fine. I am going to the previous pin again. And if I just hold the multimeter against the pin without putting any pressure on, it doesn't show me anything. If I put some more force with the black probe on the pin, then it shows a better continuity path. Not sure what's happening there. I mean, the other pins were definitely more convincing to me in terms of continuity, so yeah, there could be something going on there. Maybe it's not that nicely connected. I don't see any signs of liquid damage on the right here, which is where the pin goes to. So I don't think the problem is there. I think it might be with the actual pin and maybe with the port itself. So I mean, it might be worth to just replace that regardless, because well, it's simple enough to do that. And I will remove the USB port the same way as with controller number 2. So I will first, with the soldering iron, desolder the ground points. And after that I will turn the board around and heat from above, and that way take the USB port off. The reason why I'm going over, why I'm removing the ground hole solder first, is because hopefully that way it does not take as much heat to take off the whole USB port, since I want to prevent popcorning the board. I mean, a few days ago I had a first experience with popcorning a board. It was a PlayStation 2 board. Basically, right here, you can see a very discolored spot. And here's where the board popcorned. And now I know why it's called popcorning, because it happens without any warning, just out of nowhere, just pop. And then, yeah, this part of the motherboard just delaminated, and I cannot use this board anymore, unfortunately. At least it was already faulty, so it's not the biggest loss. And of course I could also always use the analog sticks or the LED. So definitely some useful parts on there, but yeah, it's a little bit unfortunate, of course. But anyway, let's go back onto the topic and start with the soldering iron to get the ground holes clear. So that is step 1. And now I will add a little bit of flux to the port. Might not be necessary per se, but yeah, just to be sure that the port goes off nicely. And then I'm going to use the hot air station, and I believe the previous time I had to increase the temperature to 400 degrees Celsius, so I will just go there straight away. And I will get the airflow speed on 4 out of 10. The good news is that it seems like all the pads have survived, so that's of course always good. Only the plastic in the board has melted, but that's not very surprising. Let me show you the old port. You can see there's not that much. Oh yeah, now it's in focus. If it wants to focus. You can see there's not much left of the inside. It has completely melted, so yeah, this is going into the trash. And what I'll do now, I will switch back to the soldering iron, and I will just clean the ground tools out a bit more properly. So I will add a little bit of new solder first, and then I will go over it with the soldering pick again, and yeah, just clear it out. And after that, of course, we can put the new port back on, and I will just solder that on without the help of hot air, since if it's not necessary to put in the heat. And if I can help it, I don't want to put too much heat into the board. But this is easy enough to solder, so I think that will be fine. Now that is the ground leg. So that should be fine. The ground are a little bit fragile. Or maybe I think I also have my temperature maybe a little bit too high. But as long as you have one ground intact, it should be okay. These will still connect. Yeah, we can see that there is continuity between the pin 4 and ground. I'm not sure if that's supposed to be like that. That doesn't really make sense to me. So I will clear that out with solder and try to separate those two pieces. Yeah, I think right now they are completely separated. So that was definitely not supposed to happen. It would be very interesting if that was the fault. But of course I'm not too sure about that. Let me also test the pin 4 and the point where it's supposed to go on the board and see what type of continuity we get. And it seems to be a little bit better. Not as convincing as I would have hoped. I could put a little trace on there to reinforce the connection, of course. I mean, what I can do is just get a little pen, I don't know what it's called. But this helps to remove a little bit of the solder mask. And I can just get a different point. Get some of these solder masks away. And see if between these 2 points, if the continuity is any different, if it is more consistent. Yeah, there we go. This is almost instantly in connection. And there it struggles a little bit. So what I will do, is I will get a little bit of enabled wire. So this stuff. This is coded, so I will get the soldering iron. And I will get a little bit of the coding off, and then I will just reinforce the trace between the pin 4 and this point. Or honestly, I could just get it to the point which I just removed with the little pen I had. So I think I will do that. And hopefully that reinforces the connection a little bit and makes it a bit more consistent. So I need to burn off a little bit more. Okay, let's try this. Okay, that is in position. So now I will try and bend the rest of the wire. Yeah, I was afraid that would happen. I also just squared off another component, and I'm not sure how that happened. Might be the hot air that knocked around some components. But yeah, I'm not too sure. Okay, that seems to be in place. And yeah, I think with the hot air I knocked off the other components. Because the two resistors where these pins go to are both knocked off. I had no idea, I did not notice it at all. Fortunately, I seem to have lost one component, so I will try and find that. The other one is right here. Should be able to see that. No idea how that happened. Okay. Here's one resistor who put it right there. No idea where the other one went. Okay, let's focus on the tracer pair first. So there should be a stronger connection now. And it definitely is more strong. So it seems to be successful, the trace repair. I will cut off the wire. This is always a little bit tricky. Probably put a little bit of solder mask on there to make sure it doesn't try to connect with the other pins around it. So I found the two resistors that go right here and right here. So of course we need to put those two back on. I will use the hot air for that, but I will use around 250 degrees Celsius. And I will first tin up the pads where the two resistors are supposed to be, so hopefully that makes it a little bit easier. So there we go. And now the more challenging part is to get those resistors on again. And need to make sure that the components do not go flying away. That's the most tricky thing about this. Just need to hope that they want to go into place relatively easily. Just need to go into place. I think that might be sufficient. I can do a little measurement to make sure that those resistors are into place. That's fine. Now the other one. Yeah, it seems to be okay, so luckily we were able to find the resistors and put them back where they are supposed to be. So that's good news. So before we are going to reinstall the port, I'm going to quickly put on some solder mask where we did the trace repair to make sure that it doesn't short out anything. And after that I will be back to you to reinstall the actual USB port. So now that the solder mask is cured, we are going to put on the USB port. And just like I did with the previous USB port replacement, I'm going to put a drop of super glue on the front to reinforce it a little bit, because based on the problems I found with all of the controllers, I'm not really convinced that the port is a very strong construction, so to say. But yeah, anyway, now we are going to resolder the ground legs first. So after testing the controller on my computer, unfortunately the symptoms are exactly the same as before we did anything to the controller. So the controller does not want to show up onto the computer no matter what, even if I wiggle the cable around or clean the port somewhere. I tried a few different things, but yeah, no dice unfortunately. So it seemed like something else was wrong with the board. I also attempted to clean the motherboards with some IPA, just some true cleaning, just in case maybe there was something obvious, shorting something out that caused it to not be working. But unfortunately, that also had no effect. So after that, I decided it would be a good idea to take the motherboards, both of them, under the microscope. So now we're going to look a little bit more in depth to this controller to the microscope. And the first thing you can see here is that in one of the connectors that connects the two motherboards together, you can see a little bit of discoloring in the second row, and then on the right side you see on one pin there's a little bit of corrosion, and also on the inside of the connector there's also a little bit of a discoloration. So I tested with a multimeter to see if it was still connected to each other, and the pin did end up testing fine, but it did struggle a little bit to show up. So I decided to go over it with a soldering iron to give a little bit more strength to the connector. And yeah, after that I tested it again, and unfortunately it had no effect whatsoever. So yeah, then I had to look a little bit more in depth on both of the motherboards, and yeah, unfortunately I did not see a lot of good things under the microscope. You'll probably be seeing now footage of the analog sticks, which are completely rusted on the outside and also on the inside, very dirty. I completely missed this for whatever reason. I don't know how, but it is in very bad condition. And yeah, of course I did notice the rust on the one of the potentiometers, but I did not realize that the whole analog stick was just completely busted. But even that was not necessarily the end of the world, because of course the analog sticks can be replaced. So if that was the only thing rusted, then it's still no big deal. But yeah, then I started to look around some traces on the motherboard, and yes, he noticed there was a lot of water damage in those traces, and that was on various places on the board. So yeah, in short, I had to call it on this board eventually because there's just too many things wrong. And yeah, I think the corrosion has been sitting in various places on the both of the motherboards for a significant amount of time. So even if I was to fix one thing, then yeah, there's probably another thing also wrong. And yeah, I did not think it was worth my time to fix this motherboard. So I called it on this one, and I will keep the motherboards around for parts. And I don't know what I want to say. So yeah, this motherboard is not fixable, and this also marks the end of this episode. And hopefully, in the next episode, we can actually try and fix some Xbox controllers. We still have 4 more to look at, so that should be interesting. So thank you for watching, and hopefully I see you in the next video.